Today we are going to see cascade form of realization. That is the third form that we are going to see today. This is the given transfer function y of s upon u of s. This is the given transfer function. For that, we have to obtain the cascade form realization. In cascade form realization, we have to separate this into so many transfer functions in cascade. That's why we have to factorize further. If you factorize that, what you will get s plus 1, s plus 2 upon s plus 5, s plus 3 and s plus 0.5. So this way we further factorized this. This can be written as cascade of 3 transfer function s plus 5, s plus 1 upon s plus 3, s plus 2 upon s plus 0.5. We have to realize these 3 transfer functions separately, and we have to cascade. So we have to realize each in controllable canonical form. Controllable canonical form. For that, let us consider each one can be named as H1, H2, H3. H1 of S, H2 of S multiplied by H3 of S. Let H1 of S be Y1 of S upon U of S. The input is taken as input and new output is Y1. So this Y1 will be input to the next state, next block. That's why Y1 of S, its output is Y2 of S. Next block is Y2 is the input and output is Y of S. So if you cancel Y1 and Y2, you'll get Y of S upon U of S. Now consider the first, and we have to consider Y1 of S upon U of S. That is equal to 5 upon S plus 5. That is equal to, for controllable canonical form, we will assume that Y1 of S upon X1 of S multiplied by X1 of S upon U of S, where Y1 of S is upon X1 of S is assumed as 5 and X1 of S by U of S is assumed as 1 by S plus 5. So now if you cross multiply X1 of S, this is assumed like this and this. Then X1 of S upon U of S equal to 5 upon 1 upon S plus 5. If you cross multiply, you will get this implies S plus 5 X1 of S equal to U of S. So this can be written as X1 dot plus 5X1 equal to U of T, or X1 dot equal to U of T minus 5X1. This is one equation. What is the next part is Y1 of S upon X1 of S. That is equal to 5. Therefore, y1 of s equal to 5x1 or 5x1 of s. That is y1 equal to 5x1. This is another equation. So we can obtain the controllable canonical form for this. Let us assume that x1 is available. So we subtract 5 times x1, and if you add u of t together, you will get x1 dot. If you integrate this x1 dot, you will get x1. Now we have to get y1. y1 is 5 times y1 is, this is x1. You multiply this by 5 times, you will get y1. So this is one part is over. The first part is over. Now consider the second part. S plus 1 upon S plus 3. That is equal to what we assumed, y2 of divided by y1 of s. Therefore, y2 of s upon y1 of s, that is equal to y2 of s upon x2 of s multiplied by x2 of s upon y1 of s equal to s plus 1, and this is 1 by s plus 3. Now consider x2 of s upon y1 of s equal to equal to 1 by s plus 3. This implies s x2 of s plus 3 x2 of s equal to y1. Or x2 dot equal to y1 minus 3x2. This is one equation. x2 dot equal. If you write for y, if you consider the second part s plus this, what you will get is y2 of s upon x2 of s equal to s plus 1. Therefore, what you will get is y2 of s equal to sx2 plus x2. y2 equal to x2 dot plus x2. The equation is x2 dot equal to y1 minus 3x2, and another equation is y2 equal to x2 dot plus x2. Assume that x2 is available. Take 3 times x2, add this is y1 minus 3. y1 minus 3x2 is x2 dot. If you integrate this, you will get x2. Now y2 equal to what? x2 plus x2 dot. That is y2. So second equation also over. Now we have to consider the third equation. That is y of s upon y2 of s. That is equal to y of s upon y2 of s. S plus 2 will be s plus 0.5. s plus 2 upon s plus 0.5. So that is equal to y of s upon x3 of s multiplied by x3 of s upon y2 of s. So consider x3 of s upon y2 of s equal to 1 by s plus 0.5. This is equal to s plus 2 multiplied by 1 by s plus 0.5. If you cross multiply, you will get, I'm writing directly, x3 dot equal to y2 minus 0.5 x3. We got one equation. Consider the second part. Consider the second part. Consider the second part. What is that second part? Y of s upon y2 of s equal to s plus 2. Sorry. Y of s upon x3 of s equal to s plus 2, or y of s equal to s x3 of s plus 2 x3 of s. That is equal to y of t equal to x3 dot plus 2 x3. This is another equation. x3 dot. If you combine these two together, you will get the third equation. What is the third equation? Third realization. That is x3 dot x3 is available. x3 is available. Take x3, multiply 0.5 times. Multiply 0.5 times. You will get x3 dot. x3 dot. If you integrate this, you will get x3. So what is y? Y is sum of 2x3 and sum of x3 dot. x3 dot. That is y. That's all. If we cascade all these three together, you will get cascade form of realization. Cascade form of realization. Cascade form of realization. So we combine all the diagram together so that you will get here, this is u of t plus 5 times, this is x1 dot 1 by s, this is x1, then y1 equal to 5 times x1 is y1, 5 times x1 equal to y1. Now combine this second you have to combine. Y1 is the input, Y2 is the output. So if you combine this, you can directly connect this Y1 here, and you have to subtract 3 times x2. If you integrate x2 dot, here x2 dot, here x2. What is y2? Y2 is sum of x2 and x2 dot. That is y2. Now you got y2. Here y2 is the input and y is the output. So you connect here. Y2 is, that is x3 dot. You put 1 by s, you will get x3. Here we have to multiply 0.5 times. 2 times y, 2 times x3 and 1 times x3 dot. If you multiply, you will get y. This is realization of h1. This part is realization of h2. This part is realization of h3. This is x1 dot. This is x1 dot. This is x2 dot. This is x3 dot. This is y. So we have to write expression for x1 dot, x2 dot, and x2 dot, x3 dot, and y. Let us write x1 dot. X1 dot equal to 5x1 minus, this is minus, u of t minus 5x1. 5x1. x1 and x2 dot equal to what? x2 dot equal to y1 minus 3x2. x3 dot equal to what? x3 dot equal to y2 minus 0.5 x3. But in state equation, y and y2 should not be there. That's why let us write y1 equal to what? 5 times x1. Therefore, 5x1 minus 3x2. This is also equal to y2 equal to what? y2 equal to consists of two components. One is x2 and x2 dot. 5 times y2 is y2 equal to, here this y2 equal to x2 plus x2 dot. Therefore, instead of y2 we can write x2 plus x2 dot minus 3 minus 0.5 x3. x2 dot equal to what? x2 dot equal to, already in the previous equation we got, that is 5x1 minus 3x2 minus 0.5 x3. That is equal to, if you group x2 together, you will get minus 2x2 minus 0.5 x3. So we got x3 dot. x3 dot. This is second equation. x2 dot. This is first equation. Now we have to write expression for y. Y equal to what? Y equal to 2x3 plus x3 dot. That is equal to 2x3 plus x3 dot equal to 5x1 minus 2x2 minus 0.5 x3. If you combine x3 together, you will get 5x1 minus 2x2 minus 1.5 x3. If you put them in matrix form, you will get x1 dot, x2 dot, x3 dot equal to x1 dot equal to 1 u of t 5x1 minus 5x1. That's all. All other two are 0. x2 dot equal to 5x1 minus 3x2 0. No u. Next one is 5x1 minus 2x2 minus 0.5x3. Notice that these off diagonal elements are 0 in this form, and here also u equal to 0. This is A matrix and this is B matrix. That is x dot equal to ax plus b u. We got. What is y? Y matrix equal to 5 minus 2, 1.5 multiplied by x1, x2, x3. D matrix is 0. D matrix is 0. Q of t. No need to write this. That's all. This is state model of cascade form. Notice that off diagonal elements are upper off diagonal elements of A matrix is 0. That is also having some advantage. As far as interaction is concerned, you will get less interaction than a complete non-zero A matrix. We'll compare with cascade realization. That's all about cascade realization.